Hey there. In this video, we're going to talk about normal distributions and kind of set you guys up to solve like a variety of problems that involve normal distributions. So our objectives are to compare a data distribution to a normal distribution model, determine proportions of percentiles from a normal distribution, and compare measures of relative position in data sets. So we're going to focus on the second objective, which is to find proportions for normal distributions. In the last video, we used the empirical rule, which basically says that we know that 68% of the data fall within plus or minus 1 standard deviation, 95% between plus or minus 2 standard deviations, and 99.7% fall between plus or minus 3 standard deviations. Okay. So here's a question that we might want to ask, right? What proportion of scores are below 6? Okay, so we have a normal distribution which shows ITBS vocabulary scores. Okay, we can see that the mean is 6.84, and then one standard deviation is, whatever this increment is between these two tick marks. Okay. So because a score of 6 doesn't fall exactly 1, 2, or 3 standard deviations from the mean, it's going to be impossible for us to answer this question using the empirical rule. Right? We can use the empirical rule to figure out the percent of scores that are below 5.29, right? Because we know that's exactly 1 standard deviation below the mean. But 6 is a fraction of a standard deviation, so the empirical rule doesn't apply. However, we can still answer this question using another method, which is called standardizing. So to standardize means we need to calculate exactly how many standard deviations a data value is either above or below the mean. Okay, so we know that 6 is a fraction of a standard deviation below the mean, but we need to calculate exactly how much of a standard deviation. Just from eyeballing, it looks like it could be like half a standard deviation below the mean, maybe a little bit more than half a standard deviation below the mean. So we need to figure out exactly what that is. Okay. All right, so the method we have for standardizing is called the z-score. Okay. And it's a pretty simple formula. We're going to take the value, subtract the mean. Okay. That gives us the difference in whatever the original units are. And then we divide by the size of the standard deviation. Okay. Symbolically, we use x to represent the value, mu to represent the mean, and sigma to represent the standard deviation. All right, so let's say we've performed that, right? And we've figured out what the z-score is. Okay, how can we then use the z-score to figure out the percentage, okay, or the percentile? Well, we're going to talk about 2 methods. The first method is called table A. Okay. So you should have, so on your formula sheet, there's a copy of this table. And in every stats book, it's going to be either somewhere in the front or the back of the textbook. All right, so let's say that we found a z-score, and I'm just going to make it up here. Okay, so let's say the z-score is negative 2.13. And we want to figure out the percent of values that have a lower z-score. Okay. Well, using this table, what we would do is we would look up the first 2 digits. Okay, so here on the left side, negative 2.1. And then we would look up the last digit that's in the hundreds place, right? The 0.03. Okay. And then where that row and column intersect in the table, okay, gives us the percentile. Okay. So we could say that about, 1.66% of values fall below this z-score. Or have a z-score smaller than negative 2.13. Now, tables are how things used to work, before, we had technology such as graphing calculators. So a lot of students nowadays will just use their calculator to figure out the percentile. Okay. And so here's the command, and I'll show you how to use this command in the next video. It's called normal CDF. The inputs are a lower bound, an upper bound, and then a mean and a standard deviation. Okay. So we're trying to find the area here that's shaded gray. Okay. For the lower bound, we just have to choose a really large negative number, right? So negative 1,000 works pretty well. Okay. The upper bound is kind of the right border here, which is the z-score negative 2.13. Okay. The mean is 0 because when you standardize a bunch of values, the mean will be 0, and the standard deviation is 1, again, because when you standardize, that becomes the new standard deviation. Okay. So you can see that the value that the calculator gets is pretty close to what we have in the table. In fact, if we were to round this to 4 decimal places, since the 5th decimal is an 8, then that 5 would round up to 6, and it would perfectly match what we have here in the table. All right, so here's a general strategy for solving normal distribution problems. Number one, you should always draw a picture, right? Always sketch the normal curve, scale the number line, shade the region of interest. Okay, and then we need to perform some calculations. Okay, since we're not going to be using the empirical rule, we need to convert the original data value into a z-score, and then take that z-score and convert it to a percentile. Okay. All right, so I'm going to end the video here, and then I'll do a couple examples in the future videos.